All right. Good. Okay, so what we're going to look at today is averages. Ooh, averages. You thought integrating improper partial fractions were difficult. Now, we need to worry about 3 different types of averages that we could be asked to calculate. So the 3 different types of averages we have is, first one is the mean average. Then the second one is the median average. And the mode.
What's the name of the lesson?
Averages. So what is the mean average firstly? So yeah, this mean average is you sum the data over how much data you have. What about the median? The middle one. And then the mode? Yeah, the most frequent. And that's the 3 definitions. Although what maybe is a little complicated is that our data can be given to us 3 ways. We can have it as a list, a frequency table, or a group frequency table. So the easy peasy one is if it's a list. So I'll just do 5 numbers and I'll calculate the mean, the median and the mode for those 5 numbers. So the first one, example, let's say I have 3, 1, 2, 6, 0. Well, the mean average will be 3 plus 1 plus 2 plus 6 plus 0 all over 5, which is 6, and that's 7, 8, 9, and 3, 12. 12 over 5, which is 2.4. 2.4. That's the mean. Now, how do you calculate the median? Very good. You have to put them in ascending order. 0, 1, 2, 3, and 6. So then the median of these numbers would equal 2. Because you can easily spot what number's in the middle. You go, get rid of the first and the last, get rid of the first and the last, and this is the number you're left with in the middle. Yes, what do you do if you have 2 numbers left in the middle? Yeah, you add and divide by 2 if there's 2 numbers left in the middle. So for example, if I was left with a 2 and a 3 in the middle, the answer would be 2.5. So that's the median. But maybe this one here, the mode, here, what's that? Well, there is none, because none of the numbers repeat. All of them happen once, so there's no mode average here. But if I was to stick in now an extra 0 here, the total would still be 12, but what would I be dividing by now? 6, and this here will be 2. And then I have an extra 0 here. So like what you said, Curdy, first, last. You'd be left with 2 numbers in the middle, 1 and 2. So now it would be 1.5. But now in this case we do have a mode. What's the mode? 0. So, I mean, that's something you probably have seen before. Mean, median, and mode. Now, what about if it's a frequency table? And I'll just go back for a moment. If you want to write the formula down a bit more formally, it's sum the data over n, if you want to write it down like this. But you know it anyways. Okay, what do you do if your data is in a frequency table like this? So 0, 1, 2, 3, 4. 6, 2, 6, 3, 1. How do you calculate the mean here? Yeah, because if you think about it, you have the number 0 6 times. So it's like 0, 0, 0, 0, 0, 0. And you have the number 1 2 times. So it's like 0, 0, 0, 0, 0, 0, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 4. That's all your data. So what's a quick way to calculate the mean here? Well, as you said, Sadiq, you multiply the frequencies by the data over the sum of, yes, frequencies. What now? Yes? No? Well, I haven't calculated yet. So what you do is, what? I'm giving you this as a fact. So I'm telling you, if you want the average from a frequency table, this is what you do. You multiply the x's and the f's together. So firstly, what would I get here? 0, and then here 2, and here 12, and here 9, and here 4. And then you divide by the total frequency, which is 6 plus 2 plus 6 plus 3 plus 1. Can someone type that in, please? You got it already? What is it? 18 in total? No, impossible. The final answer, what is it? Oh, you're telling me 18 for the denominator? No, give me the total answer, please. Again, don't do your sitting there looking stupid act. You have a calculator, take it out and type it in. What? You have a calculator, don't you? Sorry, I should say don't sit there looking stupid, or sitting there eating croissants, or sitting there drinking coffee, or whatever. Please type this in. 3 over 2. 1.5, thank you. That's how to calculate here the mean. What's the mode here? 0 and 2 both happen to be most frequent here. So do we say the mode is 0 or 2? In fact, we don't. No. So again, there's no mode here because there's no clear most frequent number. Because 0 and 2 both happen 6 times. So there's no mode here.
Isn't it 6?
No. The mode is the x, not the f. So no mode, okay? Now how about the median? How can we get the median? Well, it's the middle number.
Sorry, is that
1.5. That's what I was told. It's not. I'm disappointed with whoever gave me that answer.
It's 1.4.
No, 1.5. No, Sarah, what's typically?
It's specifically 1.5.
Yes, it's 1.5.
Okay, all right. Thank you, Brenton, for your contribution there. Okay, and likewise we said that there's no mode.
Yes, I thought that was 2, not 4.
That is okay. It is okay. At least you come to all your classes. And also, you know, if I gave you a break during the class and I told you, now make sure you come back to class, you wouldn't, for example, not come back to class and go home. Right, Brendan? It seems like that. Yes. I said yesterday, where did Brendan go? And Avenue tells me, oh, something came up, he had to go home. After I told you not to go anywhere during the break. Okay, right, so no mode. And what about the median? So how do you find the median? What you do is you count up the total frequency So how many, what's the total frequency here? What did we say it was? 18, wasn't it? Yeah. So you got to imagine you put these numbers in order. So what would be at the beginning? 0. And at the end? 4. So how many zeros do I have here? 6. So if you were counting out and you wanted to get to the middle of 18 numbers, what's the middle of 18 numbers?
9.
Well, it's actually 9 and 10. Because it's an even number, the middle is 2 numbers. It's only when it's odd if the middle is 1 number. For example, if I have 3 numbers, what's the middle of 3 numbers? It is the second number. But if I have 4 numbers, the middle is actually shared by the second and the third number. Okay? Likewise, if I have 18 numbers, the middle is shared by the 9th and the 10th number. So when you look at this, you have to see what is the 9th and 10th number. So yeah, well, 1, 2, 3, 4, 5, 6, 7, 8, and the 9th and 10th number will be in here. So in both cases, the 9th and 10th number is what? 2.
True 9, 10. What's 9, 10?
Oh, for goodness sake. All right, watch carefully. If I was to write these numbers out, I know imagination is difficult, so if I was to write these numbers out, look at what I'd get. 0, 0, 0, 0, 0, 0. There's 6 zeros. And then how many ones? 2. 1, 1. And then next? Yeah. The 9th and 10th number would be, well, there you go, let's see. 1, 2, 3, 4, 5, 6, 7, 8. 9th and 10th number is both 2. So the median here, well, 2 plus 2 over 2, it's just 2.
Why did you take 9 and 10?
Because there's 18 numbers in total. And the middle of 18 numbers is the 9th and 10th number. Yeah? Yes?
But why did you do this? It's easier if you just looked at the x and arranged it on 2. That's it.
What do you mean arranged it? Like what I just did there?
No. From the x values 0, 1, 2.
No. No, it was only a coincidence that it was in the middle of those lists. It doesn't have to be.
Okay. That's just in terms of frequency.
Yes. Now, just so you're clear, if you want to know as a pattern, what is the middle of one number? Just 1. 2 numbers, it's the first and the second number. 3 numbers, what's the middle? The second number. 4 numbers? Second and third. 5 numbers? 3.
But
So,
he told us that we should take the mean of
if you have 2 numbers in the middle, please be quiet. Yes.
So we don't have 2.
Oh, we do. We have 2 numbers. They're just both 2. See? 2 and 2.
I understand, but
Yes?
we don't consider them the middle number until we divide them.
You're right. Yeah. 2 plus 2 over 2. Yes. That is the middle number. Yes. Just so you can help remember, notice if it's even, like here, 4, 2, what would be the next one here? It'd be 6. What's the middle of 6 numbers? 3 and 4. If it's even, what you do is you divide by 2. 6 divided by 2? 3. So it'll be 3 and its neighbour 4. So likewise, 4 divided by 2? 2 and its neighbour. It's only when it's odd. What you do is, what's half, when you divide 3 by 2, what do you get? 1.5. Round up, and that's 2. 5 divided by 2? 2.5, round up, 3. So the first thing you do is you divide by 2. If it's 2.5, you round up and you're done. If it's not a decimal, if it's like in the example here, 6 divided by 2 is 3, then you take its neighbour. So you either do 2 things. You either round it up, and if you're not rounding up, you're taking its neighbour. Okie dokie. Yes. Okay, another example now. uh, Now let me make this one have a clear mode. Now, let's do the easy one first. What's the mode here? Yeah, but you can't, that's not a number. Yes, good. So you don't say 1 to 3, you use the middle of that, and the mode here will equal 2. Because data must be numbers, it can't be intervals. So what you're doing here is, it's like you're replacing x with roughly its midpoints. Midpoint here, 2, 5, 8, 11. Yes, it's the most frequent number. You have 10 of them. No one else do you have 10 of.
What if we have 5 to 10?
If you have, for example, 1 to 5, yeah.
5 to 10 and 10.
Well, you wouldn't. You would just still use like 1 to 5, still the middle of those two numbers, which would be 3.
Oh, we always use the middle.
Oh yeah, regardless of its size, because the middle one is the best estimate. If I said x is between 1 and 3, the best you can do is say it's 2. Yeah? 1.5. That's the mode. The mode is 2. Let's get the median next. So how many numbers do I have here? What's the frequency? 15, 16, 17, 18. 18 numbers. 18 divided by 2 is 9. So I have to take its neighbour, which is 9 and 10. So, in fact, that's nice. Both 9 and 10 live in the first bin. So what's the median here? Is 2. Because you can think of the 9th and the 10th number as both the same. It's roughly going to be 2. I have no idea what that question is. Say it again. Okay.
What do you mean by 9 and 10? Why did you take it from the first?
How many numbers do we have in total? 18. So divide 18 by 2, it's 9. It's not a decimal, so do I need to round it off? No. So I must take its neighbour. Remember? I just showed you 2 minutes ago.
I remember this.
This thing.
Yeah.
So the middle of 18 numbers is the 9th number and the 10th number.
So we take the sum of the f.
So, 1 second, the 9th number and the 10th number. The first 10 numbers are where? In the first box, aren't they? So if I was to ask you where would the 9th number be, which bin would it be in? The first one. And where would the 10th number be? First one.
If you say like the first 4 numbers, it's the second one.
No, the first 4 numbers is also in the first bin.
Then when will it move to the
Well, the 11th number. Where's the 11th number? That's in the second bin. Think about it. The first 10 numbers are in the first bin. So the 11th number would have to start then in the next one.
Oh, okay.
Yeah. Is it simple? I don't know. You have a question, Sarah? No? Are we clear about how I got the median as 2 here? Yeah? Yeah, alright. Now the last one now is the mean. So it's just like before. We multiply the f by the x. But instead of using 1 to 3, we have to use its midpoint number, which is 2. So 2 times 10, 20. 5 times 5, 25. 16, 11, all over 18. What's that, please? Brendan, get calculating.
6.9.
What is it, Curdy? 6.9?
Oh, I got it.
That seems a bit too big.
I got
4? Curdy. Yeah. Yeah? What did you do wrong?
I forget the.
Yes. What? But if you forgot the 11, your answer should be smaller than 4. Did you divide by 8 instead of 18?
No.
Or whatever. Yeah, whatever. Okay, so that's mean, median, mode for a list of data, a frequency table, and a group frequency table. There's only one time thing left to do. I didn't put any questions in the exam and the worksheet on it. It's not actually in the syllabus. I normally do it each year, and it has come up on the exam once. It's not on the syllabus. I normally do it. It has come up on the exam once. Stupid exam, stupid face. Yeah. So the last thing to do, which I'll just mention as a small example, and it's really not that difficult. We have a mean average, a median average, a mode average, and now the last thing, which is very unlikely that you'll see in the exam, is called a weighted average. What's a weighted average? Well, that's just when each piece of the data has a different level of importance. And a very good example I'll give you will be your maths results. What? So here's the result here. So your first one was your mid-semester. So let's say that was 100. Second exam was derived. Let's say that's 90. End of semester 1, let's say that's 80. Your project, let's say that's 60. And then your final exam, let's say that's 30. A nice steady improvement as time goes on, yes. Now, these are your results. And then underneath is what's called the weights. That is how important each result is. So if you were to add these up and divide by 5, that is wrong. That is not your average grade, because each exam has a different weight of importance. How much was your first exam worth? 10%. So its weight would be 10. The second one, how much was that worth? 10. This one? 30, 10, 40. So if you want the average here, what you do is, like with the frequency table, you multiply, I'll call this x, the data by its weight, and you divide by the total weight, just like with a frequency table. So here it will be 1000 plus 900 plus 2400 plus 600 plus 11200. And what would the total weight be here? It should be 100, because you're adding these of 10, 10, 30, 10, 40. So please tell me what you get here. What is it?
52.
Are you sure? 52. Is it 52? I thought it seemed... It felt too low, 30. What is it?
61.
That's it, much better. Because 61 here is a B. You're having a bad day, Curdy. Having a bad day. Okay. So, that's called weighted average. Okay, weighted average. So all you do in a weighted average is that you treat the weights as if they were frequencies. That's all. But just so you know I called it weighted average, which sounds different, because you might think it's a lot like what I did with the frequency table. But you must understand the difference is this. It is wrong to say you have 10 100% exams, right? It's wrong to say you have 10 90% exams, because those 10, 10, 30, 10, 40, that is not a frequency. It's an importance level, it's a weight. I don't know if you do anything like this in biology or chemistry, weighted averages, no?
Chemistry.
No.
How we calculate the MR?
Oh, you take each piece of data and it gets multiplied by a number, and then you divide by the total multiplications, yeah? Okay, so then you have done something similar before in chemistry. But like I said, it's unlikely to come up in the exam, although it has come up once in the last 6 years, which represents 12 exams. But as you can see, it's not very difficult, so you just need to be familiar with the word. A weighted average is like a frequency average, doing it this way. So we have mean, median, mode, and weighted average.